Welcome to Brain Vision.
So we want to calculate the total binding energy of boron 11. First thing we want to do is note the binding energy is given by the following formula. C, the number of protons times the mass of the proton, plus N, the number of neutrons times the mass of the neutron, minus mass of the entire atom, so the mass of boron 11, all multiplied by C squared, the proportionality constant between the mass differential and the energy. So for boron, you can see that the atomic mass is 11. Z, the number of protons, is 5. Therefore, the number of neutrons must be A minus C, which in our case is 6. Plugging in these values here, we find that E, binding energy, is equal to 76.21 mega electron volts. Now in part B, we're asked to calculate the binding energy from equation 43.11 in the book, which has the following lengthy form. C1 times A minus C2 times A to the 2/3 minus C3 times 2 minus 1 in our case over A to the 1/3 minus C4 A minus Z squared over A, and then usually plus or minus a fifth C5 term, but in our case this is 0 because Z is odd and A is even for us. Therefore, we can calculate the total binding energy using the values of C1 through 4 given in the book, and we can find the binding energy using this formula is 76.67 mega electron volts. The percent difference between these two answers is just the difference of the answers this is a 76 over 76.21, our calculated value from part A. If we multiply this by 100 to get the percent, we find that we get a value of 0.61% difference, which means that our equation gave us approximately the same answer as directly calculating the mass differential.